All right, hello. We're the Wearable Pulsometer group, and my name is Stephen Allegri.
My name is Megan Hively.
I am Jeffrey Cubberly.
All right, let's do this.
All right, if you're wondering what a pulsometer is, it's basically a monitoring and measuring device that can measure heart rate or pulse rate. Think of it more of like a watch where you could actually wear it. As you can see, the picture in the center kind of shows a connection between the device and the Arduino. The Where the red arrow is pointing, that's the actual device that we are basically diving into, and we're going to actually later on show you a whole schematic of what that actually looks like. And detection for this could occur in real time, or you could store it for later. And then it's also known as a pulse watch or pulsograph.
Okay, so an overall introduction of our project. Some of the goals we expected to accomplish are to create a device to gather, process, and store pulse information from the user in a wearable device. Also, overall goals for the course were to expand our knowledge on circuits, biomedical devices, and the interaction between the two. So far in the project, we have completed the circuit schematic and completed a full list of parts and materials that we would need to order, and finally the Arduino code.
All right, so this is a schematic that we essentially found online. It was written by this guy named Joel Murphy, and it serves our needs quite well. And so, what we did for a good portion of, you know, the class time that we could actually interact with each other. We analyzed these different components of the circuit, try to find out like what they did, and I'll just give you a brief overview right here. So as you can see on that number one shade box, that's essentially a capacitor to make sure that the LED that is emitting the light for our photodiode to pick up, to make sure that LED actually stays on. So I don't know if you guys know this, but Arduinos essentially uh, don't really create good analog signals. They are primarily digital, and so what they do is they do short little like pulses of uh, uh, like signal that can essentially just turn the LED on and off. What that capacitor does is it kind of ensures that the LED stays on and is emitting light rays. And then at that second little square, that is our actual photodiode. It's a 3-pin photodiode. That's what's going to actually be transmitting the signals through the circuit. And you can see the part number down there. That third little box is actually a bandpass filter to essentially make sure that only the correct signal gets to our op amp and then to the Arduino. Essentially, we're trying to limit that frequency to be somewhere between 1 and 1.67 hertz, which is around the same frequency as a human heartbeat. That little fourth box right there is a safety diode to ensure our circuit stays safe, and the Arduino for that matter. And that fifth box there is our actual op amp to strengthen the signal to the Arduino. And as far as materials and parts go, here's I guess, general list of the things that we need for this project. So far, in that little figure on the bottom, you can see that we have already ordered a couple parts that we probably won't be able to use, but that's all right. So this is just sort of like our general parts list. It's nothing too unique. I guess the most difficult part to get your hands on was a rail-to-rail op amp, but even those aren't too hard to find.
All right, so as you can see, the code does look pretty scary. It's actually not too bad. In the first little section, it's just instantiating all of your variables. You want to be able to calculate beats per minute for your heart rate, so you had to have a variable to calculate the time in between each beat, which you would be reading from the sensor. As far as the setup, you're basically just initializing all your variables. Essentially what this code is doing is it's going through creating a box and displaying a waveform, as well as in text it's also outputting the value of that waveform as well. If you go on to the next slide, it just shows you the remainder of the code. It's not too complicated. I believe it's pretty straightforward. A lot of this code was available online, but for simplicity, we took out a lot of unnecessary components and kind of refined it to better suit our project needs.
Okay, so in terms of next steps, we have a picture of our project roadmap that we had planned before all of this happened. So we got obviously to the assembly of a physical prototype, which obviously is no longer a viable option. So we are planning to finish our project more conceptually. So this will include our report explaining how we would put our device together and how the circuit and code and hardware would all work together. And then we're also considering adding more of a research component since we aren't going to be putting together a full prototype. And with that, we're considering researching how to better filter out the footsteps and movements and where on the body it would be best for the pulsometer placement and other possible research topics.
All right, and here are references.
Feel free to check those out if you feel like it.
Yeah. All right. Well, thank you guys for watching.